Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and as you know, currently we are on the second module of this course, that is process management. Within this module, we are trying to understand that how does the operating system manage the CPU by providing this abstraction of a process, right? And within the second module, currently we are on the fifth topic, that is time sharing. So within this topic, we will understand that how does the operating system share the CPU time among the various processes, right? So we have a computer system. The fundamental problem that we are trying to solve via time sharing is that we have a computer system which has a limited number of CPUs. That is the common case, right? We have a limited number of CPUs, and the number of programs that users want to run is way more than the number of CPUs. And to solve this problem, we have this concept of time sharing where the operating system shares the CPU time by switching it very frequently among all the different processes in the system, right? So this kind of gives an illusion that all of the processes are running at the same time. This is the fundamental idea behind time sharing. So now, in the previous few videos, we have talked about time sharing, its origin, right? Now we are going to start looking at how it is actually implemented inside the operating system. We are now going to talk about the implementation part, right? So time sharing is implemented via this concept of CPU scheduling, and that is what this video is about. We are going to introduce the concept of CPU scheduling and see how it is used to implement time sharing. So without further ado, let's get started. So let us start the discussion. So the very first fact that I want to start with is that time sharing is essentially a resource allocation problem, right? So if you see this diagram for time sharing, which we have been seeing for quite some time, right? If you see, there is a hypothetical computer system that I have taken where there is a single CPU, right? And there are n number of processes that want to execute on the CPU. And the way the operating system solves this problem, as we know, by time sharing the single CPU among all of these processes. And to time sharing, it will basically switch the control of the CPU frequently among the different processes so that each of these processes gets to execute on the CPU for some time, right? Each of the processes gets a slice of the CPU time, and all of them thus make progress. So if you carefully look at this scenario, what is happening? It is essentially a resource allocation problem. Here we have a resource which is kind of in limited nature, that is the CPU time, right? The resource that we are concerned about is CPU time. And then apart from the resources, we have several entities that care about this resource, that want to use this resource, and these entities are the processes, right? So obviously there is not enough resource, the resource is limited, and the number of entities that want to use this resource is more, right? The number of processes that want to run on the CPU is way more than the number of CPUs. So what is the problem? There is a resource that is limited, and there are multiple entities that want to use this resource. So how do we solve this problem? Very simple. The only way is that we have to share the resource between all of these entities, right? That is why we have time sharing. So we need to share the resource. That is the basic idea. So that is why I said that time sharing is essentially a resource allocation problem. So the way the operating system will solve this is that it will figure out how to allocate the CPU time, that is how to allocate this resource among the different processes. This is the fundamental problem that the OS has to solve. It has to figure out how to do the allocation of CPU time among all of the different processes, right? So if we look at this time sharing diagram in a different way, right? So this is the timeline diagram. As you can see, again, we have a hypothetical system which has three processes, P1, P2, and P3, and we have a single CPU. And this is the time, right? So as you can see, the first bar, the first axis, this is the CPU time. And the way each of these processes, basically the way the operating system solves the problem here, that we have more number of processes, that is we have three processes, and we have a single CPU, right? So this resource is limited, and the number of entities that want to execute on this resource is more. So as you can see, operating system is time sharing the CPU among the different processes. And the way it has done this is that for initial few time units, it has allocated the CPU to process P1, then the process P2 gets to execute on the CPU, then process P3, and in this way you can see this CPU time has been allocated to different processes, right? So the fundamental challenge here is to figure out how to do this allocation. This is the important part. If the operating system can figure out how to do this allocation of CPU time in such a way that all of the goals of the system are met, right? What are the goals of the system? First of all, the CPU utilization should be good. The CPU, which is a important resource, which is a limited resource, should not be idle. So keeping the utilization high is one of the goals. And another goal is to be fair, right? So there are multiple processes P1, P2, and P3. If the CPU is only given to a single process, then the other processes will starve, and even the user would not want this. So another goal of like this allocation is that this allocation should be fair. So we can see that although not all of the processes have got equal time, but roughly all the three processes got to execute on the CPU. So we can say that this allocation is fair since all of the processes got a chance and they were able to make progress, right? So apart from utilization, being fair is also another thing. And we could also say that being responsive is also another goal, right? So it should not be the case that the allocation is fair, all of them get equal time, but P1 gets to execute first till completion, then P2 gets to execute till completion, and after in the last P3 gets to start. So it should also be the case that the system should respond to each of these processes, right? So all of them should basically it should be a kind of frequent switching. It should not be the case that one process starts and the other processes get to execute the CPU after a very long time. That would not be responsive for all the processes. So being responsive could also be one goal. So how does the CPU does this allocation and what are the goals depends on the kind of system we have. Different computer systems will have different goals for this allocation. So whatever is the goal of the system, whatever is the type of the computer system, according to that we can define the goals, whatever the goals we want to fulfill, and depending on the goals of the system we will solve the resource allocation problem. So this resource allocation problem that I talked about, which is constrained by some goals, right? This resource allocation problem is fundamentally called CPU scheduling. This is a formal term that is given in the computer science jargon, right? So this resource allocation problem that we just saw, it is known as formally CPU scheduling. So what is the definition? CPU scheduling is a resource allocation technique used by the operating system to decide which process gets to use the CPU at a particular time. Quite simple, right? So as you can see, as the time is increasing, at different instants, the CPU changes from one process to another. So at this instant, if you talk about it, it has to stop process P1, and now it can either allocate to process P2 or it can allocate to process P3 depending on some criteria. The operating system chose process P2, right? Again, if you look at this time interval, right, when process P2 is halted, again we have a choice here. Should we allocate to process P1? Should we allocate to process P3? So depending on some criteria, the OS has chosen process P3. So this selection, right, this selection of which process has to be assigned to CPU, and not just the selection, also uh, the OS has to halt the process, select another process, resume another process. So all of these small tasks that are linked, so that basically we are able to switch from one process to another, and we are able to do it frequently, right? So there are several switches in this timeline, as you can see. So making that switch happen has several important parts. You have to stop the process, select some other process, switch to another process. So we'll talk about this, but all of this comes under CPU scheduling. So it is basically a resource allocation technique used by the operating system. And the fundamental part here is that the OS has to decide which process will get to execute next and make that switch happen. So this is CPU scheduling, right? And this word scheduling that you see is something that is not new, right? It is something that we have come across in our daily lives also. So just to give you an example, you can see we schedule tasks in our daily lives, right? So let's talk about the time when you used to go to school, right? When you used to go to school, I have taken one example. There are many examples of scheduling in our lives, but let's take this single example when you used to go to school. So when you used to go to school, you had a schedule for the entire week, and what did that schedule look like? It basically consisted of for every day and for different time slots there were subjects assigned, right? For example, if you see there are different days, and on a particular day for each time slot there are different subjects like math, English, science, Italian assigned, so that you as a student, basically the school can teach different subjects and cover all the subjects in the entire week. So here if you see here also, the school is basically kind of creating a schedule, it is scheduling. And what kind of scheduling here? There is the resource that is limited here is the time. Scheduling is only done, or basically resource allocation is only done when we have a limited, when we have a constrained environment. So in case of the school, the time is limited, right? So within the 7, let's say the 5 days, within the 5 days and within the school hours, the school has to teach you all the subjects that it offers in the curriculum, right? So if you look at it, the resource that is limited in nature is the time, right? So 5 days and within the school hours, it has to do it. So that is why, and there are many subjects with each subject having its own syllabus. So the school has to like allocate the time properly to each subject. So what is the entity here? The entity here are the subjects. There are several subjects and all of them have to be given a fair amount of time depending on their importance. And children also have need some break time, some lunch time, some games periods. So this is how the school will do a scheduling. It will schedule the time slots with the different subjects, right? In the case of CPU scheduling, we are scheduling the CPU time. Basically we were scheduling the processes on the CPU. So there the resource was the CPU time and the entities were the processes. In this case, the resource is the time, that is the school hour time, and the entities are the subjects. So we are scheduling the different subjects on different time, right? So you can see, and this is not just the case with the school hour, in our daily lives also, we schedule tasks, there are different tasks that we want to do, right? Within the office, within the home, there are different tasks that we have, and if we want to utilize our time properly, we allocate time to different tasks, right? So this is a concept that is something that you face across in daily lives also. So CPU scheduling is essentially a resource allocation problem which is used to solve the, which is used to implement the concept of time sharing. So this was about CPU scheduling, and now going forward we are going to talk about the different aspects of CPU scheduling. So before I move forward and talk about the different aspects of CPU scheduling, I just want to remind you of the roles of operating system and how CPU scheduling fits into a fundamental role of the operating system. So remember, the whole point of this course is to understand the operating system, and we should not forget what the operating system has been designed to do. The fundamental goals of operating system we discussed in the very beginning of the course in the first module, right? So as you can see, there are two fundamental goals of the operating system. The first one, so first of all, the fundamental goal is to manage the hardware, right? And within that, there are two parts, right? First is to make the computer hardware easy to use, and the second one is to ensure that the computer hardware is used in an efficient manner. So it's all about managing the computer hardware, right? The whole purpose of the operating system is to manage the computer hardware, and within that management comes two pillars. One is to make it easy to use, and the other is to ensure that all of the resources, the hardware resources, are used in an efficient manner. And the way it does that, we have already talked about this, is that the first part is taken care of by providing useful abstractions, right? So when we talk about making any piece of computer hardware easy to use, so what the operating system does is that it takes that physical resource and it creates a virtual resource on top of that, and that virtual resource, which we call an abstraction, is much more easy to use compared to the physical resource. It has a cleaner interface and it is also much more powerful. So if we talk about the CPU, which is the central resource in this current topic, right, current module, in the second module we are concerned about the CPU as a resource. Subsequent modules will be about different resources like memory, IO devices, but this second module, that is process management, here we are concerned about the most important resource, that is the CPU. And to make the CPU, to manage the CPU, to make it easy to use, the first part, that is providing the abstraction, we have been talking about it. The abstraction is the process. The abstraction is that of a running program, right? We have talked about process in great detail in the previous topics. That part is done. So now coming to the second goal, that is making the CPU, ensuring that the CPU is used in an efficient manner. There comes, for any hardware, ensuring that it is used in an efficient manner, the operating system has to do a careful resource management, right? And When we talk about the CPU as a resource, when we are managing the CPU, there comes CPU scheduling. So if you see, what we have been talking about is that, okay, there are several programs in the system, and when they run, they become processes. And to ensure that we can run more number of processes on limited number of CPUs, we will do time sharing, right? We will share the CPU time. And finally, to implement time sharing, we said that, okay, it is a resource allocation problem which will be solved by CPU scheduling. We have to schedule the CPU time among the different processes, right? So here is the here is where the operating system is fulfilling its second fundamental duty with respect to the CPU, that is making the ensuring that the CPU is used in an efficient manner, right? So this is the resource management part. So CPU scheduling is all about managing the CPU as a resource and allocating it to different processes. So this allocation has different nuances, different aspects, which we will talk about. But before we go forward, look at this as how the operating system is fulfilling its two fundamental responsibilities with respect to the CPU. First, it made the CPU easy to use by providing this abstraction of a process, and we have been talking about process in the last four topics, right? And now going forward in the next two in this and the next topic, we are now shifting our attention to how the operating system is fulfilling its second fundamental duty with respect to the CPU, that is making the CPU ensuring that the CPU is used in an efficient manner, and that is via doing the CPU scheduling, right? So now we will talk about what is CPU scheduling and how it is done. But remember that all of this CPU scheduling is where the operating system is fulfilling its second fundamental duty, that is of ensuring that the CPU as a hardware resource is used in an efficient manner, and that is where the operating system has to do a careful resource management. So now we are going to finally talk about CPU scheduling and how it is done. So let's take a closer look at CPU scheduling. So this is the diagram where we can see that the operating system is scheduling the CPU among the different processes. If you look at this first track, right, this is the CPU time, and this is the resource that the operating system has to schedule, and it is scheduling the CPU time among different processes, right? So let's focus on this first track and see what is happening. So if you look at this, we are switching between different processes, right, on a frequent basis. Let's take a closer look at one such switch and see what are all the things that are going on, and then we will understand what all we need to do, what all we need to have to make that switch happen. So let's focus on this first switch, right, between process. Let's take it process A, and let's say this is process B, right? So if you let's zoom this. So I have not shown that there is a small time between process A and process B that goes into context switching. So what is context switch? So as the name suggests, it is where we are switching. It is a time that is spent from where we are switching from one process to another. So there are whole bunch of little things that we need to do to ensure that we switch from one process to another, and that is called context switch. It is the set of things that we need to do to halt this one process and start this another process. We'll talk about context switch and what all things are done in great detail in one of the subsequent videos. But this is how basically the switch looks like. There is a process which was running, and then it is halted. There are certain set of things that we do to halt this process, select another process, and then we start another process. That comes under context switch. Since it's a minor thing, we have not shown it here, but yes, there is a certain amount of time that is spent on each whenever we switch. There is a context switch. So whenever, if you look, there is a transition. At each of these transition, we do a context switch, which has not been shown in this first track, but it is there, right? Now if you look at context switch, then there are several parts here also. So first thing is that when process A is running, first thing, so to bring first thing is to bring the operating system into the picture. If you see, the operating system is not running on the CPU when process A is running, right? And if the operating system has to do something, if it has to do any kind of scheduling, do any kind of switching, first of all we need to have the operating system running on the CPU. But that is not the case. When process A is running, it's not operating system, so operating system has to be brought into the picture. So the first part of context switching is that process A has to be halted, and the control has to be transferred to the operating system. Then only any kind of CPU scheduling, any kind of time sharing will take place, right? So once the control is given to the operating system, the next part is that the operating system now has to select a new process, right? So till now, process A was running on the CPU. It was executing instruction. It was doing its work. Now it is time to give this control of the CPU to some other process, and which process should it be? That is a good question. So selecting another process requires a fair bit of policy. Basically, there are several factors that the operating system needs to consider to give the control to the next process. The CPU is a very important resource, and it cannot just be assigned to another process randomly. So this has to be done carefully, and we'll talk about this, what all the things that the operating system takes into account when selecting another process. To give you an idea, as we talked at the beginning of this video also, the different goals that the operating system has to keep in mind, whether to whether the goal of the system is to keep this resource utilization high, whether it is fairness, or is it making the system responsive, or it could be a combination of these. So the operating system has to keep all of these goals in mind when making the switch happen, right? When making the selection for the next process. Then there is the actual switch, right? So when I say actual switch, we have to basically be careful that we are halting a running program. It was running and it was doing a whole bunch of things. So when we are halting that, so that running program would be interacting with the CPU. The contents of the registers would be constantly changing as the instructions are being executed. The memory was contents of memory would be changing. The process would have some files open. It would be interacting with some IO device. So a whole bunch of activities going on when a process is running, right? And when we are halting that process, we have to make sure that we save all of the things that the process was doing, because it had not completed. Process A is being stopped before it is completing. So at a later point in time, there will come a time when the operating system has to resume process A, right? And when the time comes to resume process A, that resuming part has to be done exactly from the same state. We have talked about this, that time sharing is supposed to be transparent to the programmer, right? Time sharing should not affect the results of execution in any way, right? If you execute the processes in a system where time sharing is not implemented and all processes run from starting till execution, versus you run the processes in a system where time sharing is implemented and you're halting processes, resuming processes, in no way the results should be compromised, right? The result of execution, the overall behavior between a time sharing system versus a non-time shared system should be the same. So we have to be very careful when we are pausing a process, and when we are resuming the process, we have to resume it exactly the same state. So while making that switch, all of these things need to be taken care of. So when we say switch to next process, the state of process A at which it was executing, all of that has to be properly saved, and the state of process B, that has to be loaded, right? Process B, it is possible, very possible, that process B was executing at a earlier point in time and it had been paused and now it is being resumed. In this case, we are saying that okay, process B is executing for the first time, but it could let's take this case, right? When process B is being resumed, process B was halted here and process B is being resumed here. So it could very well be the case that in this switch, one process is being halted and another is being resumed, so that other process which is being resumed, for that process the operating system would have saved the state. So it has to be properly resumed, all that state has to be properly loaded, and the process which is being resumed, it has to start execution exactly from the same state from where it had left. So all of these things, saving the process, resuming the process, come under this part, right? And once this process is resumed, the control has to be transferred. So currently we are in, during this entire context switch, we are in the operating system, so that control has to be now given to process B. So all of these things happen within this time frame that we call as context switch, where basically we are transitioning from one process to another process. At before context switch, some other process was executing instructions. After context switch, it will be some other process. And as you can see, this context switch is quite a involved, like there are several tasks involved in this context switch, and all of them have to be done by the operating system. So this context switch is a very important part of CPU scheduling. So when we talk about CPU scheduling, to understand CPU scheduling, like what all things that we need to have in place, think of this as a problem that you're trying to solve. The operating system has been assigned this problem to solve this CPU scheduling. So what are the things that it needs to take care of? So we can think of this in terms of different questions, right? So first, there are 5 different questions that the operating system, while implementing any operating system, while implementing CPU scheduling, needs to answer. So first of all is, why are we doing this scheduling? That we already know, because it will help us doing CPU scheduling will help us to time share the CPU among all the different processes, and that will help all the processes to make progress. That will create the illusion that all of the processes are running at the same time using a limited number of CPUs. So that we know, that is answered. Four questions needs to be still answered. What are those four questions? First part is how, next is when, third is who, and last is which. So let's talk about these questions. So when we talk about how is basically, so how will we perform CPU scheduling? When we talk about how, the first of all we need to have a mechanism in place which allows us to switch from one process to another. It first of all, it should be possible to do the switch. Before we talk about which process to switch to, when to switch to, first of all it should even be possible to halt a process and resume another process. So that is where we design mechanisms so that this how part is solved. When we talk about how part, we should have to first have mechanisms in place which make a switch possible, right? And for that there should be mechanisms to transfer control to the operating system. Then we should be able to switch to next process. That is, I talked about the things that are involved when we switch to another process. We have to carefully halt the running process, resume another process, and finally we should be able to transfer control to the next process. So these three things, one is the transferring control, switching part, and then transferring the control back. All of these things first of all should be even possible to do, and for that we need to have several mechanisms in place, and all of those mechanisms come under the how question. So the how question, answering the how question, that is how to do CPU scheduling. First of all, you have to design mechanisms that allow to make a switch. Once this is answered, then the next question that is that the operating system has to think about is when. Right now that we know that okay, switching from one process is to another process is possible, the next question that the operating system has to, while designing the operating system, one has to answer is that when should we do this switch. So we'll study about this in the next videos, that there are two options. As an operating system, you have two options, that when you should schedule the CPU, when you should make this switch. One option is that you should allow the process to run as long as it wants to, and only when the process has voluntarily given up the control of the CPU, then only you assign the CPU to some other process. So when I say process is giving up the control on its own or on a voluntary basis, it is because, let's say, it is terminating because its job is done, or it is blocking because it is doing some kind of IO operation and it does not need to use the CPU. These are cases, that is termination or blocking, when the operating system, when the process in question is giving up the control of the CPU on its own. And if we decide to do CPU scheduling only when the process is giving up the control, that kind of scheduling is known as non-preemptive. And the other part, the opposite of that is preemptive scheduling, when we can do scheduling at any time, when we can take the control of the CPU from the process, even if it does not want to give up the control, we can do it in a forceful basis. That kind of scheduling is known as preemptive scheduling. Here the operating system does not wait for the process to give up the control on its own. It is more ruthless, and it is allowed to basically take away the control of the CPU in a forceful manner, right? So there are two possibilities that you have to take into mind, whether you want to do the scheduling only when the process is giving up the control, then such a scheduling is called non-preemptive. And the other kind of scheduling is that okay, you are allowed to, you're designing an operating system where scheduling can happen even if the process is not has not given up the control on a voluntary basis. So here scheduling can happen forcefully. So this is called preemptive scheduling. So this when question is also important, when to do it, whether process is giving up the control only then, or anytime the scheduling can happen. So preemptive and non-preemptive are two different approaches which kind of depend on when you decide to schedule. So the first part is answering how to schedule, where we were okay making the switch possible, making the scheduling even possible. Second question was about when to do the scheduling. Third is who will do this scheduling. So obviously we know that it's the operating system that will be doing the scheduling, but the operating system is a vast piece of code. It's not it has several different components, and the entire operating system cannot be dedicated to just scheduling. There is a special component, there is a special piece of software that we call as CPU scheduler, and it's the job of the CPU scheduler to do all of these tasks that is related to CPU scheduling. So who will do this CPU scheduling? It's a dedicated component inside the operating system, which we call as CPU scheduler, right? So this CPU scheduler, it will have many different tasks. That is, it must be having, it should be keeping track of all the different processes that are there in the system. Only then it can do the time sharing. Once it is aware of the different processes that are there in the system, it should also be aware which processes are ready to execute and should be considered for scheduling, which are in the waiting state and should be kind of excluded. Even if we assign the CPU to a waiting process, it won't do anything. So it should be aware, okay, which processes are running, which are ready to execute, which have exited, which are in the waiting state, and then only it can make a proper decision. The scheduler should be aware of what is the goal of the computer system, whether it is improving utilization, or it is about responsiveness, or is it about keeping the system fair to all the processes, or is it about combination of different goals? There could be some other goals also. So all of this the CPU scheduler must be aware of, because it is the one which will decide which process to assign the control of, to which process the control of the CPU has to be assigned. It has to make a careful decision, right? And that decision determines the overall performance, the overall usability, the overall user experience of the system. So it's very important. It's a very important responsibility that the CPU scheduler has. And finally, which question answers the part of this selection of the next process? To which process should we schedule the CPU? So this which question is about selecting the next process, and there are a whole bunch of policies which we'll study in the next topic. So the whole entire next topic is dedicated to studying different policies that are there for selecting a new process to be assigned the CPU. So there are different goals, as I said, that a computer system can have, and depending on these different goals, we have different policies, or you can say algorithms, that optimize for different goals. So this is basically a policy question, which is about answering that to which process should we assign the control of the CPU. So once we have the answer to all of these questions, we can say we are able to perform CPU scheduling. So just to summarize, first of all, we said that we need to be aware why we are doing scheduling. We are doing this scheduling so that we can implement time sharing, so that we are able to run multiple processes on limited number of CPUs. How the how question is about making it even possible to do the switch. You have to transfer the control to operating system. We have to halt the process, resume another process, save context, all of that, and then transfer control to another process. Then the next question was about when is about when do you want to schedule, whether it is only when the process is giving up the control voluntarily, or the scheduling can happen at any time. That is it non-preemptive or is it preemptive? Then who will do the scheduling? It is the CPU scheduler, and we discuss the different responsibilities, the different tasks that the scheduler must perform. Then finally, the which question is about answering to which process should be assigned the CPU. This is about the selection. So it is important that we answer all of these questions, and then only we can say we have implemented CPU scheduling. So in this topic, we will be answering these three questions: how, when, and who. And in the next topic, we'll answer which. So the which part, we'll spend a lot of time understanding the different policies, and there are different interesting policies that exist for deciding which process should be assigned the CPU. So this is the overall flow that we are going to follow, right? So this was about understanding the different questions that we need to answer when we are about to implement CPU scheduling. And finally, I would like to conclude this video by taking an analogy, which we had already taken in one of the previous topics, and just summarizing all the different aspects of CPU scheduling using that analogy. So let's see what is that analogy. So I had talked about this analogy of a music DJ and time sharing in an earlier video also. In the first topic towards the end, in this module only, in this process management module, we had talked about how time sharing is very similar to what the music DJ does. So let's recall that analogy. So if you look at time sharing, what is happening? What is the operating system doing? It is kind of switching the different processes on the CPU, right? And in the same way, what is the music DJ doing? It is trying to create a music mashup, and for that mashup, it is switching different music CDs on this CD player, right? So these scenarios are in some way similar. Not everything will match. So there will be many things that are different, but the switching part, right? There is a resource. In the first case, it's the CPU. In the second case, it's the CD player. And the switching part, that is, in time sharing, we are switching the processes on the CPU. In the music DJ analogy, here the DJ is switching the CDs on the CD player. That part is common, right? So using this analogy, I want to explain the different questions that we raised in CPU scheduling. So think of as a OS designer, that now you're going to implement a CPU scheduler, and before implementing that CPU scheduler, as I discussed, there are several questions that you need to answer as an OS designer. So what are those questions? How, when, who, which? And I already explained these questions in the context of CPU scheduling. Just to make things more understandable, let's correlate this with the analogy. Like, let's understand what do these questions mean in the context of this DJ analogy, since the overall thing is similar, right? Overall, at a high level, we are trying to switch, right? In first case, we are switching the processes on the CPU. In the second case, we are switching the music CDs on the CD player. So these questions will also kind of correlate. So the first question that I talked about is the how part. First of all, it should even be possible to make that switch. You have to be able to transfer the control to the OS, halt the process, save its context, resume another process, and give back control to another process. So that was what is the how question in the case of CPU scheduling. So let's take the music DJ example. In this case, what does the how question mean? The how question means that when a music is being played, right? Currently some music is being played and we have to switch to some other music. So the how part is basically answering how should you stop the music. There must be some button that we will be pressing to halt the music, right? And we'll also kind of take note at which point the music was being played, because we, as we discussed, we want to resume the process exactly at the same point. And let's just assume that we also want to resume the music exactly at the same point where we are pausing. So the DJ will first halt the music by pressing some button. It will take out the CD, take note of mental note of where the music was being played, and then bring in another CD, put that CD, press the play button, and all these things have to be done, right? So all of these things need to be figured out. That is how to stop the music, how to save, like take a mental note where the music was being played. And when you're bringing in another music, it might be the case that it had been paused in a previous time and now you're resuming that music, so you want to resume the music exactly at the same point where you had left off. So all of these concerns, and finally when you're playing the music, you'll hit some button. So this how part is about figuring out that how to make that switch even possible, right? So this is the how question, and how you should think about, kind of correlate the two scenarios of CPU scheduling and this music DJ, right? The next part is the when. So in the case of CPU scheduling, it was answering whether we are allowed to perform the scheduling at any time or only when the process is giving up the control. In case of this music DJ analogy, the DJ has to figure out when should it stop the music. Like, should it stop the music only when it has finished, or it has to stop any point in between, or it will stop it at fixed stanzas, right? So this is something that the DJ needs to figure out while doing this switching. At which point should it, like, what is a good point to stop the music? Is like, at any point, is it good to stop the music, or should it wait for a logical point to stop the music, right? Then the next question is the who question. Who is performing the CPU scheduling? We talked about the CPU scheduler and what are the different roles that it has. In this case, the switching is obviously being performed by the music DJ. So think of the CPU scheduler as the music DJ. In the case of the computer, the CPU scheduler has to switch different processes. In the case of this DJ analogy, the music DJ has to switch different CDs. But who is doing it? In our first case, it's the CPU scheduler. In our second case, the DJ, right? So the scheduler is like the DJ, right? And the final question is answering to which question, to which process should the control of the CPU be assigned? That is a very important question. So in the case of this music DJ analogy also, I think this is the most important question. To which should be, what should be the next music to be played? Currently some music is being played, and to make a good mashup, the next music that is to be played has to be good one. So that choice is what the DJ has to make, and that is a careful choice. To which CD should the next switch happen? So all of these questions need to be answered in the case of the music DJ analogy also. So I hope this correlation kind of helps you to understand what are the questions that you need to answer in the context of CPU scheduling. This music DJ analogy is a simpler one, right? You kind of correlate what are the things that we are trying to answer in order to implement the overall CPU scheduling, right? So guys, this was about this analogy, and this was about this video. We talked about that time sharing is essentially a resource allocation problem, and it can be solved by CPU scheduling. We talked about that CPU scheduling is a fundamental duty of the operating system, where it is ensuring that the CPU as a resource is being in an efficient manner. Then we discussed the different questions that one needs to answer while designing any CPU scheduling system, right? The how, when, who, which, right? And finally we correlated all of the concepts with the music DJ analogy, right? So guys, this was it for this video. Thank you very much for watching. I'll see you in the next video. Thank you.